Hello, welcome to PVS the Tutor. Today in the mathematics we'll be looking at trigonometry. So we're going to look both at the sine law and the cosine law. Now, go straight to the point. This is a 2018 GCE question 8. It says three varieties A, B, and C are connected by straight paths as shown in the diagram below. So we have A, B, and C. Given that AB is equal to 15 kilometers, angle ABC 79, and angle ACB is equal to 40 degrees. Now the question says, calculate the distance AC, the area of the triangle ABC, and the shortest distance from BC to AC. Now we need to take into consideration what ratio are we using. Are we going to use the sine rule or are we going to use the cosine law? Now, for the fact that we have two angles and one side, we're going to use the sine law, and we've got only three sides. So, we're going to pick the side that has got an angle and an angle without a side. So, we know that we have sine C going with side C, which is equal to sine B going with side AC. So since this is B, so this is side B. Now since this is angle C, this is side C, and since this is angle A, this is our side A. So angle B is going with that side. So there we have side B. So we need to go on and plug in the numbers there. So we have sine C, that is sine 40 over distance C is 15 kilometers. And sine B, that is sine 79 over side B. Now, we know that we are going to cross multiply there. And we are saying side B is equal to, hence we are going to say side B is equal to 15 times sine 79 over sine 40. Hence this will lead to B will be equal to, we need to punch sine 79 times 15 divided by sine 40, and we are having 22.9 kilometer. So take note of this side, because once you mess up finding the length AC, all your answers that are going to, all the questions there, because the questions that are coming down, they will be based on the value of B that you are going to find. So take note of B as 22.9 kilometers. Question 2 says, area of the triangle ABC. How can you find the area of triangle ABC? Now remember, when a triangle is like this, if this is A, B, C, you get the sides that are being subtended by an angle. For example, in this case, we need this angle because we have this side and we also have that side. So this leads to, for us to find this angle, we have 79 here and we have 40 here. So say, since 79 angles in a triangle, they add up to 180. So our angle A in this case is 79 plus 40, 180 is 61 degrees. So this is the angle that we need to find in the area of our triangle. So therefore, we are saying area of a triangle is equal to half side C times side B times sine A. In this case is half times Side C we have is 15 times side B, the one we found earlier, that is 22.9 times sine 61 degrees. Now we need to calculate our area by saying our area is equal to sine 61 times 22.9 multiplied by 15 divided by 2, and that's going to give us 150.2 kilometer squared. Remember, area is measured in square units. Take care of the area as well, because at some point you'll be required to use it. Now, for us to find the shortest distance from BC to AC, let's first sketch our triangle. Our triangle is something like this, where we have our A there, and we have our B there, and we have our C there. How do we find the shortest distance? And they're saying from B to AC. So at some point you are going to see that this line is perpendicular to this L line AC, and it's forming a 90 degree. So what do? We say the area of a right angled triangle should be equal to the area of a non-right angled triangle. And we know that the area of a right angled triangle is half HB, and the area of our triangle, the one we found at first, of course, we found that it was 150.2 kilometers. Since our area of a non-right right triangle is AB sine C, so at some point this should be equal to this. So we are going to use this to find the shortest distance from B to AC. Let's see how we can do this. So we are saying it's half HB should be equal to 150.2 kilometer squared. So now all what we need is to remain with H. H is the height, of course, from there I'm sure you saw. And we are going to say, for us to remain with H, this one is the same as HB over 2. That will give us 150.2 kilometers squared. Hence, we are going to cross multiply there, and hence we say 150.2 times 2, and that will give us 304. So we are saying HB. Now we have our B. The B is the distance that we found at first, which is AC, which is 22.9 is equal to 300.4. So we say over 22.9 divided by 22.9. Hence our H will be equal to 13.1 kilometers. Remember, like that. Part B says solve the equation cos theta is equal to 0.937. Now for us to solve this, we need to make theta the inverse of cos. So we are going to say theta is equal to cos inverse of 0.937. So our theta will be equal to, so when you say the cos inverse of 937, it's giving us 20.4 degrees. Now you need to take note. The question says for the values of 0 degrees less than or equal to theta less than or equal to 360. Now we are going to pick cos. Cos is positive in what quadrant? Now what we know that this angle will keep it as our reference angle, 20.4. So you can write it somewhere 20.4 degrees. So therefore, we know that the quadrants, we've got the first, the second, the third, and the fourth. In the first quadrant, all the ratios, that is sine theta, cos theta, and tan theta, they are all positive. Now, in the second, only sine is positive, and the less than negative. In the third, only tan is positive and the rest are negative. And in the fourth quadrant, only cosine theta is positive and the rest are what? Are negatives. Now, our answer is going to lie in the first and in the fourth quadrant. So in our first quadrant, our value of angle, it will be the same 20.4 degrees. That is between 0 and 90 degrees. Now, our second value it will lie between 270 here and 0 or 360. So what do? We are going to subtract 360 minus 20.4, and we must have an angle there, 360 minus 20.4, and we are having 339.6 degrees. So this and this here, these are the angles which they wanted. Take note of the quadrants when you're asked. Question C says, sketch the graph of y is equal to sin theta. Sin theta is just an oscillation graph. So the maximum value of a sine theta is 1 and the minimum is -1. So that's how far the graph can go. And it will start all the way from 0 there, it will come and like there. Now you need to take note. They are saying between 0 and 360. And if I say this should be 180, so my second value will be 360, and it's going to end there, and it makes a full wave. So that's a full graph of a sine theta. If you want, you can draw as many as this. So you can put 90 there, then you can put 180, you can put 270, you can put 360, and the graph will go like that, goes up, comes down, like that. And you discover that there will be a maximum of two waves. When you multiply them by 2, you are going to have, of course, one complete oscillation. So thank you so much for watching. Don't forget to subscribe, don't forget to share, and don't forget to comment. Please subscribe and support your fellow Zambian. Thank you so much. I'm PVS the Tutor. I'll see you in the next video.